Thank you, Dr. Sargia. Thank you for the time for me to present our research, my research and team about the hybrid power plant. First, I must say thanks also to Professor Antonis and Professor Tumiran here. Professor Tumiran is also my teacher too, my mentor. Okay, so as explained by Dr. Sargia, today I will present my research in challenges in isolated island hybrid power plant development in Indonesia, when I and my team support the subsidiary company of PLN to develop the hybrid power plant in Indonesia. As explained also from Professor Tumiran, that Indonesia is the largest village in the world, consists of 5 major islands: Sumatra, Kalimantan, Java, Sulawesi, and Papua, and about 3 smaller groups. There are total number of 17,500 islands, of which about 6,000 there are inhabited. Thus, the electricity of 6,000 inhabited island is challenging, especially in east part of Indonesia, as explained from Prof. Tumiran before. So, according to the Ministry of Energy and Mineral Resources, in the last of 2021, the electrification ratio, residential absolutely, in Indonesia, we have 4 provinces which have a lower electrification ratio. The lowest one is the East Nusa Tenggara, and then Maluku. It's very good to explain that Maluku have lower electrification ratio. Papua, and also its central Kalimantan. If you look at this map, the East Nusa Tenggara and Maluku is the island province, while the central Kalimantan and Papua is, I think, it's a big area. Yeah. So, according to develop the electricity supply for that island, isolated island, especially for the isolated island like in Maluku and its Nusa Tenggara, we also face 3 challenges there. The first challenge is the PLN, as the single buyer in the Indonesian electricity industry, also asks the developer to meet the minimum electricity production costs. So if the PLN have the existing electricity production cost there, and then the developer should propose another electricity production cost which is lower than the existing electricity production cost. That's the first challenge. The second challenge, according to Indonesian target to meet 25% renewable energy source in Indonesian energy mix at 2025, all the electricity supply for isolated island should be give a maximum share to renewable energy. And according to several studies, we know that the only renewable energy there for Maluku and Papua, Professor Tumiran proposed the biomass, but for other countries, maybe the only primary energy there is solar PV. And the third problem there is the intermittency. If we use the solar PV to be our major supply in that isolated island, so the solution for this isolated island in Indonesia should meet these 3 objectives: minimum electricity production cost, maximum share, and the intermittency. Let's move to the technical concept solution. According to the condition that isolated island in current situation supplied by diesel power plant, it will derive to a high electricity production cost. However, since the fuel cost of solar PV is 0, then it can reduce electricity production cost. In the other side, the solar irradiation intermittency can be handled by diesel power plant, while the fuel consumption of diesel will be decreased. So the technical solution for the isolated island which implement diesel power plant is the hybrid power plant. According to our solution here, where the solar PV will be a major power plant in the isolated island, as Dr. Gadjah explained at the beginning, that currently PLN implement the desalination program. We change the diesel with the hybrid power plant. We have three concept of level penetration of solar PV in isolated island. The first is low level penetration. The second one is a medium level penetration, and the high level penetration. In the low level penetration, the solar PV, if you look at this figure, the grid frequency, since the solar PV is in the midterm power plant, still in allowable range during intermittent condition, when the cloud move to cover the solar panel and other disturbance, if the solar PV penetrate in a low level. If you look at this figure, all the intermittence here can be covered by the solar PV itself. It means that the minimum penetration of solar PV can still keep the grid frequency in allowable range. The diesel power plant, the existing diesel power plant there, must operate above 40%. According to the practical, the diesel will not work efficiently if it only operates in 0% to 4%. However, it depends on the age of the diesel. The major problem here that the major diesel power plant operated by PLN in current days is the old diesel. In low level penetration scenario, we not necessarily need a BESS here, which will working as frequency control. So only solar PV and diesel power plant. However, the problem is the electricity production cost may be lower than existing electricity production costs when only diesel support the isolated island. Even it wouldn't reach the optimum cost. That's the condition of the low level penetration concept. Since the PLN want the developer produce the lower electricity production cost, then maybe we can move to the second concept. The second concept is medium level penetration. In the medium level penetration, the grid frequency will be out of allowable range during intermittent condition. Depend on the capacity of solar PV here. However, in the medium level penetration, we still have a diesel power plant there. However, the diesel power plant must operate on 40%. And then we implement the BESS, which will working as frequency control. But the BESS here is optional. It can be adding into the grid or no, depend on the study. In this situation, the electricity production cost can be lower than existing electricity production cost, and also can be lower from the electricity production cost for the low level penetration, and may meet the optimal cost in the medium level penetration. The third concept of penetration on solar PV on the hybrid power plant is the high level penetration. In the high level penetration, it's similar with the medium level penetration. The grid frequency will be all of allowable range during intermittent condition. However, the advantage here is the diesel power plant can be out of service or can be shut down. And the BESS is mandatory. The problem here is that the investment cost for the BESS will be higher. So we maybe in this concept, the electricity production cost will be lower than existing electricity production cost, but may be higher than low level and medium level. But in the high level penetration, we can produce 100% renewable energy to support the isolated island. This is the technical concept. So I will move to the case study. What we have research and my favorite case study for the hybrid power plant is the Karimun Java Island and also Nusa Penida Island. The Karimun Java Island are a group of 27 tropical islands in the Java Sea. Incorporated into the Java Regency in Indonesia, is located 80 kilometers north of Jepara City in central Java. I think it's near Yogyakarta also. This is the demography of the Karimun Java. The total area is 71,200 kilometers. Total village is 4 villages, named 1,500 inhabitants and 2,900 households. Another solution to electrify Karimun Java is submarine cable, but it's not economic option to boost electric access in Karimun Java. Then the off-grid electric system was the only option left. If we look at the electricity development staging there, the first staging is how to bring electricity to isolated island. In this stage, the important thing is electricity can serve people even only in 12 hours, just to serve basic electricity need. In the first stage, the electricity production cost was 44 cents per kilowatt hour, since all the power plant here is a diesel power plant. The second stage is how to bring electricity in adequacy and reliable. In this second stage, the diesel power plant implement on this isolated island, while the electricity production cost was 31 cents per kilowatt hour. Since the electricity production cost is still expensive in the second stage, then we propose the third stage to deliver electricity on optimal production cost. And in this third stage, the renewable energy as primary energy will be a solution. The electricity production cost we assume will be lower than 31 cents per kilowatt hour. In the first stage of the third stage, we try to implement the solar PV there, and the solar PV can reach about 20 cents per kilowatt hour. So in the electricity development staging, the first challenge can be answered by implement the renewable energy in the location. But the second problem is can the grid handle intermittency problem in this island when the island implement the solar PV. So if we look at more detail to the Karimun Java, the prediction, the forecasting for the peak load is 1.4 megawatt. And the 1 megawatt solar photovoltaic and BESS 4.5 megawatt hour parallel with the diesel power plant, we hope it can handle the intermittent problem here in Karimun Java. This is a single line diagram for the existing grid in Karimun Java. There are 2 diesel power plants there. The first is Lagun Baja 1 and the second is Lagun Baja 2. The installed capacity of each diesel power plant is 1 times 1.8 megawatt, and the solar PV is 1 megawatt. This is a combination of a hybrid power plant. It's the concept of hybrid power plant where the important part in this concept is the hybrid controller. The hybrid controller will control when the diesel running, the batteries running, and also the solar PV. Since the major problem there is the major technical problem there is the frequency stability due to the intermittent condition, then we simulate the intermittent condition there. According to our assumption, the wind speed, the radius, and the gradient, then the maximum time for the intermittent is only about 5 seconds. When the extreme condition happen, 100% of solar irradiation will decrease to 25% in 5 seconds. In that situation, the active power from solar PV will decrease from 1 megawatt to 0.133 megawatt. It's very expensive. However, since we installed the batteries energy system there, the batteries will increase their capacity to respond the intermittency and dispatch the active power to 0.746 megawatt. The grid frequency will decrease when the solar PV panel covered by cloud, but still on allowable range, since the batteries can handle the active power loss by the intermittence. If you look at this figure, the frequency, the nadir frequency is a 49.88 hertz. So the conclusion here, the hybrid power plant is solution for electricity development in isolated island Indonesia, with a major challenge in both technical and economical. The technical solution should be increasing the renewable energy contribution and handle intermittent condition, while the solution should produce the minimum electricity production cost. So this is all my presentation from my research to support the independent power producer in isolated island. Thank you.
Thank you very much, Dr. Sudarmono, for very interesting presentation. I think that this is the smooth presentation, because the first presentation, Dr. Tumiran explained about the bigger issue in the erection, and then Dr. Sudarmono addressed in the very detail about how to the design of the hybrid renewable system. By considering maybe several scenarios, and then they are considering the technical and economical aspect. This is based also on the real project, on the real case study in Karimun, Jawa. I think this is very interesting, and please, if maybe from the participant, if you have any question, or maybe from Prof. Antonis, if you also have a question. Welcome, Mr. Marcus Lim. Thank you very much for your attending in this session. And after the break, I will maybe hear from your presentation also regarding with the design of a microgrid using a typhoon. Thank you, Mr. Marcus.
Thank you, Dr. Sargia. I'm glad to be here. Thank you, everyone.
Yeah, thank you. Prof. Antonis, if you have any question or comments, please.
I was impressed by the way that the production from PVs are expected to be reduced with passing clouds. It's something that we don't have it so much in in stronger power networks compared to this one. So large use of photovoltaics should be very careful because of this fluctuation in the stability issues. I was very impressed by that, by this slide.
Yeah. Okay. Thank you for your comments. And any other question from other participants? We still have maybe, because in the next session after break is 15:25, so we can end this session at 15:10. So we still have maybe 5 minutes for discussion. Any question from the luring participant? Because for your information that in here in UGM, we have a participant which join in the lab, and this student is a participant of the microgrid course because I and Dr. Ronnie handle this course, the design, operation, and control of microgrid. So all of the students also join in this room. Yeah, if there are no more questions for this presentation, I think we will give applause again for Dr. Sudarmono for very interesting presentation. Yeah, now I think we will have a break time for maybe 20 minutes because we should have a prayer, afternoon prayer. And after the break, we will have presentation from Mr. Marcos Lim. Is from Genetron Singapore, or the Typhoon distributor of Singapore, with the topic of the design and control of a microgrid with Typhoon, because as I informed in the previous maybe presentation that the UGM by supporting the MESfIA project from the European Union, we procure the Typhoon Hill 604. Based on this Typhoon hardware envelope, Hill is hardware envelope, we can use this equipment for the design process of microgrid, starting maybe from design, operation, and control evaluation. Because by using this hardware envelope, we can simulate what maybe Dr. Sudarmono already presented, because he also present about how to design the microgrid by considering many scenario. And using this Typhoon, I think we can do that. Then how to use the Typhoon for doing this design and control of microgrid, Mr. Marcos Lim will explain in more detail. And I think all of you, I hope, still join in this online meeting, so you can understand how this Typhoon can handle the design and control of simulation of microgrid in the real-time operation. Thank you very much. See you in maybe next 15 minutes at 3:25 p.m. See you.